Hi, today in this video we're going to be covering chapter 3.4.2, which is synthetic division. There are some concepts in here that are very useful to know that we covered in the last video where we talked about long division. But basically, when you look at synthetic division in this unit, it's important to know the concept of like placeholders. But a lot of synthetic division relies on memorization type stuff. So let's get into it. Also, ways that I learned synthetic division and the ways that I teach synthetic division, Lumen is really weird with it. Like, for instance, I wouldn't have anything written out like this. But the way that Lumen wants you to do it, it wants you to fill in every single individual box, and that's kind of annoying. So we'll just go through it together. So when we want synthetic division, we have our top, which is going to be, in this case, x cubed plus 9x squared plus 11x plus 10, and that's going to be divided by x plus 1. With synthetic division, number one, this x has to be 1x. It cannot be 1x squared. It cannot be 3x. It cannot be anything other than just 1x. 1x and, or just x, which is the same, with just the exponent as 1. And with that out of the way, another thing to note when you're doing synthetic division, so we want this to be 1x to begin with, but also we want, this number here is important, but we want to flip the sign basically. We want to set this to 0. We want to set this whole thing to 0, this bottom to 0, because we cannot have this be equal to 0. Essentially, so you'll do x plus 1 equals 0, and then you'll do x equals negative 1. And this negative 1 is going to be in your little box right here, negative 1. And the way I write it is negative 1, and then I do a little corner like that. Now, the next thing to know for synthetic division is we want to look at each of our coefficients for our variables in ascending order. So first we'll have 1, because this is 1x cubed, and then we'll have 9, because this is 9x squared, and then 11, and then 10. Now, the first thing to know with another thing to know with synthetic division is we're going to drop this first number down. This gets dropped down. And then you say, what is this number times our number in our box? And that's going to be negative 1 in this case. Then we add these together. So 9 plus negative 1 is 8. Then we do 8. Negative 1 times 8, and that will give you negative 8, and that will give you positive 3, and you'll multiply that by whatever is in your cubby, and then that will give you negative 3, and then you'll have a 7 right there. And what I like to do, and it hasn't been taught this way in class, but I think it's helpful, is to just put a little box around this. This is your remainder. So now, with that being said, now we have like a bunch of weird numbers that don't really seem to mean anything. But actually, it's really useful because now what we can do is we can say, well, there's a few different ways that people like to handle it. I personally like to say this is x cubed, so I know that my first number is going to be an x squared. So now we have 1x squared, and then we just go in descending order. And since this is positive, it'll be plus 8x, and then plus 3, and then plus your remainder divided by what your divisor is. In this case, x plus 1. Now, the way that Lumen wants you to set this up as is this will be negative 1, and we drop this 1 down, and this is a 1, and then this will be negative 1. That'll be 8. You're just basically filling in the boxes. Negative 8, positive 3, negative 3, positive 7. The remainder is 7. And the quotient is going to be this x squared plus 8x plus 3. And I don't believe it wants that plus 7 divided by x plus 1. It's kind of wonky. Yeah, so this is the answer for that problem. Maybe not for this one. Wait, did I do that right? Yeah. Okay, yeah, I did it right. So then this next problem is determine the remainder of the polynomial x cubed plus 5x minus 11x plus 1 is divided by x minus 2. Now this term, I kind of don't like what Luhmann's doing here. It says use the remainder theorem to find f of 2. We actually learn about the remainder theorem in the next chapter, so I'm not sure why they're bringing this out. But basically, the remainder theorem says if you use synthetic division with whatever it's asking you to find the remainder theorem on, in this case it's 2, then whatever your remainder for the, like in that little cubby, in that box, the remainder of that equation is going to be the actual answer. Like if it would be the same as if you plugged 2 into all of your x's, plus 5 times 2 squared minus 11 times 2 plus 1. That would be exactly the same. I'm not sure why they brought it up in the chapter before they learn about synthetic division. Before they learn about the remainder theorem, but that's what that is, and it's weird, but we have to deal with Luhmann. Yeah. Anyway, so in this case, we have x cubed plus 5x squared minus 11x plus 1, and all of that is divided by x minus 2. Now, our cubby is going to be the sign flipped, because we know this is 1x. And then one thing that we can do is, so then we want to get the coefficients. So we have 1, and then 5, and then negative 11, and then positive 1. There's no need for a placeholder in this case. So now we can drop this number down. We get 1, and then we multiply that by our cubby. So 2, which gives us 7. Multiply that, gives us 14. Gives us 3, 6, and then 7. And so our remainder is going to be 7. The remainder theorem is going to be 7 also. And then we just fill in basically what we just did. So 1, 1, 2, 7, 14, 3, 1, 6, and then 7. And that would be your answer for that equation. Now this one is basically the same. All we're doing now is just examples. So we're going to take this, we're going to flip the sign, so we have negative 2. And then we have a coefficient 1, a coefficient 10, a coefficient 21, and a coefficient 14. Well, that's a constant, but yeah. And then we drop the 1, and then we multiply that. So negative 2, that gives us 8, and then negative 16, and that gives us 5. And then negative 10, and that gives us 4. And that's our little cubby. So the remainder is 4, and our quotient is 1x squared. You don't need the 1 for it to be an answer. And we know it's x squared because we have the 3 here. What you can also do is you can move up. You can say, here's my remainder, here's my constant, here's my x, and then here's my x squared. That's I feel like that's probably a more reliable way to do it. But we all pick our poison. And then plus 8x plus 5, and that is our quotient. And then our remainder would be 4. Same idea here. We have an x plus 1, so minus 1 in this case. We have a coefficient 1, a coefficient negative 4, but we don't want to put 9 next. We need a placeholder for that missing x. So we'll do a coefficient 0, and then a positive 9. And now we can drop this 1, which is 1, and then negative 1, which is negative 5, which is 5, 5, negative 5, 4. So now we have that in our cubby. The remainder is 4. And we have x squared minus 5x plus 5 as our quotient. And same idea here. We're going to do negative 5 for our cubby. And then we have 1 and then 10. We're missing an x squared, so I'm going to do a 0. And then we're going to have a negative 124 and then a positive 7. We're going to drop the 1. So then we have negative 5, positive 5, negative 25, 25, oops, negative 25, and then that's going to be positive 125, gives you 1, and then that'll give negative 5, that'll be positive 2. So now it'll be x cubed plus 5x squared minus 25x plus 1, and then our remainder is going to be that 2. And that would be your answer. Now, if you have any questions, please let me know, and I'll answer as soon as possible. And yeah, have a good one.